Welcome to Spring LIB.
36.114, if we have two lines that are separated by a delta lambda, which is much less than the wavelength of the lower line, we want to show that their angular separation at mth order is this. So we have d sine theta equals m lambda. And similarly for delta lambda, we have that d sine theta plus delta theta equals m times lambda plus delta lambda. So if we subtract this from this, we get the d times sine of theta minus sine of theta plus delta theta is equal to m times lambda plus delta lambda Wait, I have these backwards. Oops. All right, sorry about that. Minus m lambda, and so this is just m delta lambda. So, and the limit that delta theta goes to 0, this is going to go to cosine theta delta theta. And if delta lambda is much less than lambda, that's sort of like delta theta going to 0. So this is delta theta cosine theta. So we get the cosine theta is equal to m delta lambda over d delta theta. So now we can solve this for delta theta and just sort of start massaging it into the form that the problem asks for. We have an m delta lambda over d cosine theta. You know that the cosine of theta is the square root of 1 minus sine squared. We still have m delta lambda living up here in the numerator. But we know that the sine of theta is m lambda over d. So now what we can do is bring this d into the square root, so just multiply everything by d squared. And then if we factor out an m squared from everything in here, we get an m out here. We'll cancel this out. And we will get the result that we're looking for.